Hello, everyone, and welcome to the webinar. We'll be getting started in a few minutes. So just hang out and we'll be with you in a very few minutes. Hello, everyone, and welcome to the webinar. We're going to be getting started in just a few minutes. I see some people are still joining into the room, so we're going to go ahead and give them a few more minutes to get in. So welcome and make yourself comfortable. We'll be getting started in just a few minutes. Okay, good morning, everyone, or good afternoon, or good evening, depending on what part of the world you are in. My name is Chris Murray, and I'm the Technical Marketing Manager for the Unreal Engine. Welcome to webinar number 2, the Unreal Engine for Architectural Design and Visualization. I'm going to be joined today by Fabrice Borelli, a professional 3D visualizer and a longtime 3D expert, and he's going to be guiding us through a lot of things related to the engine. So let's just go ahead and get started. For those of you that may be new to the Unreal Engine family, welcome. We've been around for 18 years as the premium award-winning real-time engine for games. We've been doing a lot of things for games. But in the past 18 months or so, we've realized that a lot of our enterprise customers are doing things with the engine in unique and interesting ways, a lot of uses for non-games. And so we've formed an enterprise team that's dedicated specifically to using the engine for issues that are using the engine for things that have absolutely nothing to do with games, like automotive and engineering and aerospace and things like that. There are over 3 million users worldwide of the engine. And of course, the engine is free and will remain free. We want everybody to have access to the engine to create some amazing things. So the free version includes the full tool set of the engine and the source code. So for this webinar, webinar number 2, let's take a look at where we've been so far. Previously in webinar number 1, it was an introduction to the capabilities of the engine for design visualization. Fortunately, it is not a requirement for today. Today's webinar number 2, is really about next steps. We're actually going to start getting into the engine and taking a look at some of the things that are actually going to help you create some amazing visualizations. Coming soon, we have 3 more webinars waiting in the wings. We have lighting and post-production. We have materials with an introduction into the Substance Designer for architecture. The folks from Algorithmic are going to be joining us for that. And also, we have a webinar coming up on VR production. So hopefully, those things will be of interest to you, and we'll be rolling those out soon. We don't have dates for those yet, but we're working on that. So here's what we're going to cover today. Today, we're going to be taking a look at the import process of 3D models. We're going to be looking at working with UVs and light maps. We're going to be taking a look at the materials and lighting pipeline, post-production effects, and interaction. Also, at the end of this webinar, I invite you to stick around for a technology preview for some things that we're working on at Epic Enterprise that are specifically related to design visualization workflows into the engine. So we're going to be showing some new things, some things that people haven't seen before. So you want to be sure to hang out and check that out. Before we hand things over to Fabrice, I just want to mention a couple of things. I think most of you have found the chat room over on the right-hand side of the screen. So please feel free to chat there and ask questions. I would like to bring your attention to a question button. If you hover your mouse where you're going to type in your message, you can see there's a little balloon. That's also a drop-down box. And if you click that drop-down box and choose a question, you'll get a dialog box that looks like this. I'll go ahead and answer a question there. So you can go ahead and type your question in using that designation. And that's really important because this will help us separate comments from questions. We're going to be doing questions at the end. So I want to make sure that we're able to record your questions and that we can get back to them. So please, if you ask a question, go ahead and use the question designator. So I think that's pretty much it. Oh, there is one more thing. We're going to do a thing called a classroom poll. And we're going to be doing that a couple of times throughout the webinar. And I'm going to do one right now. So I'm going to post a poll to the room. Let me go ahead and pull that up. Let's start here. I'm going to ask our first question of the class. If you could go ahead and answer those questions for me, I'd be really interested in seeing who was attending the first webinar. So we'll give people just another minute or so to answer that. Okay, that's good. Justin, I see your question. I'll see if we still have a live link for that. I don't have access to it at the moment, but I might be able to provide that. The good news is, Justin, is you don't need you don't need to have watched webinar 1 to get anything out of this webinar. This webinar will stand alone on its own. Okay, so looks like we have the majority of the people did not attend webinar 1, and that's perfectly okay. So I'm going to go ahead and end the poll for now. So it was 42% yes and 58% no. So good. We have a lot of new people in this webinar, and that's really great to see. So I'm going to go ahead and turn things over to Fabrice. So Fabrice, I'm going to stop my screen share, and then you can pick up and take it away.
Great. Thanks, Chris. And I'll come on screen and say hello to everybody. Very nice to see you all here. And let's get cracking. I'll show you my screen, turn my webcam off, and share. I'll assume it's all working fine. So welcome to the Unreal ArcViz webinar number 2. So in this webinar, we are going to talk about workflow. So like Chris said, the idea is really to give you the tools you need to create projects a little bit like right now. So I'm going to show you a range of things, and what we're going to concentrate on today is the workflow to go from A to Z, all the things you need to get cracking with the software. So for that, we are going to start comparing these two workflows. One I call V-Ray workflow, and the other one, the Unreal workflow. So what does that mean? V-Ray, I mean by that the offline rendering workflow. I kind of assume a lot of us will have used V-Ray in the past and will know what we're talking about that. So it's more, if you use any other renderer, that's absolutely fine. The V-Ray workflow, so it's all about things that we're very familiar with, and I've just broken it down into this series of steps, which is obviously an illustration. In real life, it doesn't necessarily happen systematically like this, especially in ArcViz. So we'll start with our 3D model, which will either come from CAD, from Revit or Max, and then we'll apply our materials using textures and using Photoshop as a piece of software for that. And then we'll go and put our lights, environment, the sun, all the V-Ray GI and V-Ray sun and things like that we're all used to. And then we'll render out these images with certain passes and Z depth and things like that we will then put over to another software in post-production, whether it's Photoshop or After Effects or Nuke if we're doing animations and things like that. So this is all nothing new. It's laying the grounds for us to jump into what is new, which is the Unreal ArcViz workflow. So a little bit about that. Epic Games is dedicated to this idea of final pixel. So to really to generate the final pixel that you will see on screen. So for that, it's incorporated within the software some extra steps. So I'll just go into about that in a minute. Just before I carry on, though, what's this funny sign saying is that we will be talking generally about the entire process, but this seminar today is really going to be front loaded with this first part. It's all about going through the steps to get data into the engine. It's a sticky point at the moment. This is quite complicated, and there are things that we there's new things that we're not necessarily used to when we've used V-Ray before. So in we've got the 3D model, and that needs to either come from CAD or will be modeling in Max or in a other 3D app, actually, for that matter. And then we've got this new term, which is the light maps. So we'll go a little bit over that. And then moving on to the lighting, we've got these new concepts of the Unreal skylight, which works a little bit differently. And then we've got the light maps and the light mass, which is a big sticky subject. So then we'll move on to materials. And here again, we've got something new, which is the nodes of Unreal Material Editor. And then there's some ways we handle textures and maybe some new piece of software like Substance Designer and Photoshop that we've used before. So here, this is where effectively this line stops in the previous V-Ray workflow, where the post-processing, the color correction, tone mapping, and all that is handled inside the engine. So that's all the effects, and that's great for us. And then finally, interaction and output. So this is a massive subject, which I've just bundled all together in that final slide. We're not going to cover that in great depth at all here, but like Chris said, we will have another webinar which will be talking about VR, and we'll certainly talk about a lot of these things in greater detail. We are also going to have a seminar on the materials specifically with a substance designer. And next webinar is going to be about lighting, and we'll go into great depth. So here I'm just going to give you an overview of the whole thing and go a little bit deeper on some of the essential things you'll need. So moving on, you've noticed I've kept my little timeline here to kind of make things a little bit clearer for us. So when we go back, when we model for real time, for those of you who've watched the first webinar, we talked about that a lot, real time and interactive. So we're obviously using Unreal Engine. It's all about real time, and there are some things to consider. So the thing we need to consider when we want to bring our data in is where it's coming from. The software, if we import Revit models, for example, or Rhino, any CAD software is going to have different priorities than effectively a gaming software. The CAD software will be there to produce information to be issued for construction, so it will be loaded with a lot of metadata, and we can handle very, very large sets of data sets, and this is not something that is necessarily working the same way for games. So we can bring that data straight from the CAD application into Unreal, and that's an option one. We use the FBX format for that. Or option two, we go through another software. So in this case, 3ds Max, because I assume that most people use that, but obviously it's a 3D app. What I mean by 3ds Max is that it's a 3D application which is more tended towards producing images like films or advertising or games or visualization in our case. So this is option two. We'll have a look at in a minute. So here is just, I thought I'd go straight in and show you an example of taking this very simple but nice model I found on 3D Warehouse, using SketchUp and going straight from SketchUp to Unreal. So I exported just one FBX, and it's a pretty clean import, and everything's more or less there. Everything's kind of in the right, not upside down, in the right space. So it's worked pretty well. All the furniture is in there, and all the faces I seem to be showing, but there are some problems that we're having. We've got the wrong names in the file, and there's a very high number of objects. So this is something that is going to give us problems in the long term if we want to work with this file. So we've got also in this table, we've got normals facing the wrong way. The faces are facing the wrong way, so that needs to be sorted out. And we see that we've got some pretty nasty invalid light map settings. Also, Unreal was throwing me lots of error messages when I was building the lighting and things like that. So this is something that is not a massive problem to tidy up. So after a bit of cleanup, it's all sort of more or less gone back, and I'll show you the scene here that I've got straight in Unreal. You know, it's not bad. It's really only taking a few minutes, half an hour or so, and I've got all the files, all the faces here. There's no massive holes. So, okay, it works, and so I'm going to, while I'm here, to save on time for loading, I'll just keep loading these things after I've finished presenting, and then start again. So yeah, it works, and in conclusion, it's quick and it's valuable for this white card model for pre-visualization. So now I'll jump back. It's great for concept, for massing, for light studies and views. So it's something that works, but as I said, it's not ideal for long term. One thing that really, if you're going to work this way and import files straight from CAD into SketchUp, the thing to not do is to do what I did and import as one file. The thing to do is really to export different FBX files, at least to separate the building from the furniture and things like that. So we're going to go into more depth on how to organize the file for real time next. So let's have a look at that. The second option here is to go through 3ds Max, and that's going to enable us obviously to take in a lot more varied CAD data, some obviously 2D. So we'll need to model, and that will enable us to not only manage our file, but also to do a lot of other things which are on this slide. So using 3ds Studio Max is the professional workflow today. I haven't actually met anybody who doesn't do that in a professional, whether it's a visualization agency or architecture firm. It enables us to have clean geometry to manage, and because again we have to deal with the fact that everything needs to be real time, we need to enable Unreal Engine to render a large number of images per second, so we'll need to optimize. The problem with that is well, 3ds Studio Max is pretty expensive, and so I've just put Blender here because I hear that it's a viable alternative. People are really using it in the professional visualization industry, so it's something to maybe keep an eye on for the future. So once we've got our application, we're going to have three things to do in there. We have to check the geometry once it's come in, and we have to apply the light maps UV. So we'll go over that in a little bit more detail. And then we have to export. So what does that mean? We will need to keep this file organized. So thanks to Tilt Pixel for letting us have this model. It's very kind of them. And so this was a file that came in as FBX. And as you see, I imported it. It was just one FBX, and it's over 4,000 objects in here, and all these came as named as BIM-like entities, and they all came in on layer 0. So I had to not remodel, I had to reorganize this file. And so if you were to import that and the layers did come through, you would probably have to reorganize the file anyway, because the file that was given to you will probably have XREFs in, and the layers won't make sense. So it's a very good idea to begin to have a little bit of strategic thinking, of thinking how you're going to organize that so that you can carry out the 3 steps. One, which is to check. So effectively, you might even have to check each object one by one and make sure they're right, make sure the faces are facing the right way, and so on. And then we'll have to apply our light map UVs. So we'll need to be able to turn some of these layers off and make sure we've done it all. And then we'll have to export. So again, we don't want to get confused and export things twice and so on. So it's worth having a little think about that, of how that's going to be done. So I'll just jump in the UI for this one, just to show you how this building has really come very, very clean. In fact, I've used some of the for this. I've used the piece of software that Enterprise was currently working on, and that Chris will give you a demo on at the end of the webinar. But these have all come in very, very clean. It was very simple to do. I just selected the plates, and they all came in with a proper folder structure and properly named with the original name, not the name of the file, and so on. So that's really exciting for us. So unfortunately, it's not released yet, so we'll have to do some of this manually. So another thing I wanted to show you in here is how when we import our objects, we have the option to use object instances. So for example, in this facade, all the panels, there's only 3 actual panels, geometries that were imported into the software, and all these were placed using a script, which I'll give you the link in a minute. But it's a very efficient way to work in Unreal, and this way we can have a large number of objects and a very small kind of footprint this way. So again, I'll show you a little. So select all these handrails, and then because I thought I can't give a 3D demo without a teapot in it, so I'll just show you how that works really well. And I can instantly change all my handrails to beautiful teapots. But what's that basically illustrating is obviously when we've got design changes to do, and if we had to replace all these handrails in Max and 800 objects and then swap them and re-export them and so on, it would be quite time consuming. Whereas here they've been placed and instanced, and all I need to do is import one other guardrail and swap it, and then job's done. So that works very well. Another thing is now I swap back to my so if I do my little maintenance, I'll close this down and save you on staring at the screen while it's loading, and I'll open my next one. There you go. That's done. So that's that for this model. One other thing that is going to happen when we start importing data into Max is that we are going to have some issues with the geometry. So some of this could work, but it could cause problems, things which would be slightly undesirable or not enough quality, wrongly tessellated, and so on. So we will need to model in Max as well. So I've just prepared this little speeded up movie here to show again a sort of best practice where here where's it gone? I'll start that again and fast forward just to show a problem that we're getting here. That when this object, this hole in this wall was created with using a Boolean, then we got these funny lines here coming for us. And then when we do the chamfer, it's giving us a problem. So again, I have to say that the reason I did this is that I get a lot of questions, people asking me, is it okay to chamfer in Unreal? Because it's a very good practice when we model our interiors or furniture or things like that, to give that chamfer that's going to catch the light, and it gives a much better model overall. So this is sort of the answer to that question, where yes, it's definitely okay to do chamfers because it makes our models better, and for all these good reasons. But if we use it doing the original sort of Boolean and with these funny shapes which give us these problems, then we lose the control and it's working against our favor. So here I'm showing you the proper polygon modeling. I'm sure most of you are familiar with that, but if we come from CAD, it might be a little bit foreign to us. So it's something that maybe takes a little bit of working out to do, but once you've done it, it's very easy. So it gives us all the control we need over the chamfer, and I'm just going to fast forward a little bit to the UV mapping. If So we'll go over this a little bit more detail, but here you can see that my UV mapping is controlled. I know I can see where all my faces are, and all these little chamfers are appearing in the right place. Whereas in the original UV mapping, which was I can't find it anymore, but in the original UV mapping, that gave us problems because of the way it was modeled and because of the automatic unwrap. So anyway, I'll carry on and show you a little bit more of the example of this, of how we imported some data and used this instancing in here. So let's move on to my lobby scene in here. And so here we've got this lobby scene again, where typically, so I'll go full screen on that. Typically, this whole side of this lobby would have been used, would have been in a V-Ray workflow, it would have been collapsed into one object, or even possibly this entire set of milieus would be possibly one object. I would have used a clone tool, so it would have been a one object. And this is a problem that will, well, this gave me a lot of problems in this scene, because when we calculate the light map, Unreal needs to average out, to work out the lighting over this entire distance, and that creates great inefficiencies. And it actually, I'm sort of trying to draw an exponential curve there, it increases our render time exponentially. There was what I ended up doing is using these instances, so you can see that the actual, I'll just zoom in regarding the chamfers, the actual geometry is very, very detailed. There's tiny little chamfers everywhere. And so it enabled me to keep this very detailed geometry that I was able to place all these individual elements, and then they rendered much, much, much more quickly than being all collapsed into one object. For example, these rails that go over the entire length of the scene, these are very inefficient to render as well. So it would be much better off at least breaking them up. Another thing here, using in this restaurant area, the chairs. So I hope I'm not making you dizzy by moving too fast here, but the chair and all these objects were all instanced. And so if I show you that in here and select my chair, you can see that there's only one chair, and it makes it all very very clean and easy. And if I want to replace this chair, all I need to do is swap it out like this for another object. So that works very well, and it makes the file. I think Unreal is very happy to deal with things this way. So I'll just carry on back in my. So let me, if I can do my little maintenance again, and then lobby, and then I'll get ready for this one. Okay. Back into PowerPoint. So in the lobby again, we've got, this is a scene that was in French. So thank you for Artefactory actually in Paris to working with me on this, to Eric and Dominique. And so again, we took great care to separate out the layers this is rather ideal to not have too many objects to be on each layer, so that we can really keep track of them, and each one is properly checked. So yes, it does take time, but this is effectively the more professional workflow, where we will check everything, and if we've got large numbers of objects, we'll just instance them and export the one object that's been properly modeled. So this is yes, something to keep in mind as well is whether the object will be static or movable. So the static, by that I mean walls, the glass, the things that are, the floors are part of the building, and those can be exported as they are. On the other hand, the chair, which is, although it's a bit confusing because here the mobility says static for the chairs, but when I exported them as movable objects, and these need to be moved to 0, 0, 0 in space before being moved. So again, it's a little bit of strategic thinking. What is going to be static? What is going to be movable? And the movable objects like the plates and the glass need to be placed at 0.00 in space before being exported. Thankfully, we've got some scripts. So I'll just point these out in a minute that help you to do that. But before I do that, I would like to point out this asset naming convention that you can find on the wiki for Unreal Engine. This is something that I ignored at the beginning and thinking, oh, well, I can do my own naming, blah, blah, blah. But to be truthful, I came back to it because it's very good to know about this and to know that it's there. And if you decide that your things are getting a little bit confusing, then this is really here to help us. I now apply it for all my static meshes and textures and so on, and it's worth knowing about. Now, while we're talking about all the light maps and things like that, we're coming to the end of our first quadrant. So here, I know it's taking time, but as I said, we're front loading here. So light maps, some of you probably will already know that, but for the ones who don't, I will just go through a quick explanation of what light maps are. So what are light maps? It comes from the game technology, and some of you who are old enough might have done that back in 3ds Max, where we could even do it on the scanline render in V-Ray, where effectively with our texture, we've got our texture, and if we create another texture which is giving us this image. Sorry, I just realized I've got this annoying cross there. I just get rid of. And so light map, yes, this is another texture which is looks like this. And when we multiply the light map on top of the diffuse, we get the impression that the object's been lit. So this looks like a flashlight lighting this wall. So what we can what we do then is this second texture is then wrapped onto the model using the UV. So with our texture, usually this will be tiled in some way. So we can apply a UV, which will have a set size and a UV coordinate, then this image can be tiled over the object. However, we can't do that with our light map because the lighting will be different in all directions. So what we need to do is unwrap this correctly. So this is the same process as the age-old problem of creating a flat image from a round object like the Earth, so creating a map, but we're going the other way. We're putting our texture map onto an unwrapped grid, which corresponds to the 3D geometry. So I put this image here because it reminded me a little bit of wrapping up Christmas presents or presents, wrapping up a present, which it's quite an art in itself, especially if you don't want to have any overlaps on the corner. So imagine that. That's what needs to be done so that this texture is unwrapped properly. And some people say it's an art form in itself. So it's not totally simple. The reason why we have channel 1 and 2 obviously is because we have channel 1 for our diffuse texture and channel 2 for our light map. What makes things a little bit confusing is that in Unreal, we'll have channel 0 and channel 1. So to keep that in mind. So for those who didn't know what light map UVs are, hopefully this sheds some light on it. So we have two ways of unwrapping objects. One which is automatic, and to be honest, it works. Most of the time, I do that systematically. And we have the manual. The manual is really going to be there for us to sort out, well, for the other 10% when the automatic didn't work. So we have these links. So these are the scripts that most people I've heard use. You've probably already used them. If I don't use Steamroller, I use the automatic unwrap from Chris Jennings. So it's very simple. You just select all the objects and click an object, click a button, and it does it all for you. And for the exporting, I use this TS tool. So there's some great videos teaching you how to do this, placing the instances from 3ds Max to Unreal. So check that out. This is a very, very useful script that actually I couldn't do without today. So before the other solutions come in. So what what are the problems? These are the problems we get when we automatically unwrap. This is was really, I just put the unwrap modifier and then went to mapping, flatten mapping, and this is what Max did for me. So this is not great. It really is going to give us problems. It just doesn't look right. So this is what we need to do. And a lot of the time, this was a model I downloaded from a furniture manufacturer, and it required very little tweaking. It was already there. So it can be a problem if we blanket apply automatic unwrap on the entire scene without looking really at what we're doing, because we might have an object which is already perfectly unwrapped, or which might need just a little bit of modification to place these around, and then we create this. So especially on furniture, maybe have a look if I know that a lot of people are struggling with the unwrap, so this is something that we'll look a little bit deeper into when we do our lighting webinar. Okay, so just go over this briefly because I'll come back to it over in a minute when we talk about light maps. But the texture, so this, I'll go way back. This texture has, like this one, has a resolution. We will we'll talk about the resolution in a minute, but just to go back to my to the screen here, what you see that you can override a light map resolution. I've put this to 800, whichever object it was that I selected, but you can see that they're all different here. And what's a little bit a way that I would express that is the light map resolution is a little bit like a DPI when we print an image. So high DPI, we've got a very crisp image, and so with a high resolution we will have very crisp lighting calculations, and with a low resolution we'll have a coarser, less precise calculation lighting, but it will be much quicker. And this is the same thing when we have a high DPI image that we want to print high DPI. Looks very good, but it takes ages. And if we have a low DPI image, it prints quickly and it looks okay. So you'll be the judge, but this is what an expression of what this light map resolution and how important it is. So finally, we move to our next section, which is about lighting. So just before I go on talk more about the light maps and so on, this I thought would be useful to just know there's really nothing to do. It's just to know about deferred and forward rendering. So Chris, I thought we had a little poll here to know if
Yep, the poll is going live, Fabrice. The poll is live right now.
Great, excellent. Never heard of them. Most people never heard of them. All right, so I will try and explain. Basically, Unreal Engine is a deferred renderer, works with a deferred renderer. Actually, this is not true because it also is a forward renderer as well. Now they've implemented it in version 4.14, but it's been a deferred renderer for years. And so what does that mean? This image illustrates a little bit. It's a little bit like we had several renderers that are stacked on top of each other like layers. And these would be the layers. Each renderer renders a different image. And effectively, it's a bit like when we do compositing and add all our passes in Photoshop. So this is what the engine does. And the reason why it does that is related to games. I think it's got to do with number of lights and maybe speed and so on. So I think it was just a strategic decision. Anyway, that's the way things are. And I'll point out how that impacts us in a minute. But as opposed to forward rendering, which is the way V-Ray works, where we've got the camera and V-Ray just fires a ray from the camera, and when that ray hits the geometry, it queries what's going on with the lights, materials, and so on, and returns a pixel. So there's sort of one pass, and then the deferred rendering, I think it might be 7, or I don't know quite how many. But looks like there. So that's in mind, this is the new workflow in Unreal. We've got our skylight, and within that skylight, we will put whether it's the default Unreal Sky, we've got HDRs, we've got also the possibility to add blueprints to illuminate our scene, or to give the sky illumination. And the skylight is going to be the element which will throw the light. So it'll take the color of the environment. In what Unreal also will do is use the environment color. So this is where you see the different renderers at play, where in V-Ray, for example, if we had an environment color and then a skylight, the environment color would be completely ignored, would be overridden by the skylight. In Unreal, that's not the case. They will both add on top of each other. Here again, also the atmospheric fog will contribute to the lighting of our scene, whereas in the V-Ray workflow, what's done most of the time, for example, is to add the fog in post-production. So the fog will have no impact on the color of the scene or the color that the skylight will take. So next one is the direct light, the sun. That's pretty straightforward. There is no sun. It's just the direct light. So in V-Ray, we've got the V-Ray sun. Here it's just the direct light, and obviously the particularity of the direct light is that all the rays are parallel. So that's what makes it look like the sun. So this is the new term, the light mass. Light mass will take care of the bounced light, the GI. In this case here, it's shown the floor, but obviously in a scene, it will be the light bouncing off each surfaces and illuminating things like dark corners and shadow areas and so on. Another new thing for us is the reflections. So these reflection probes are great because they take in, a little bit like our skylight, they will sort of take in a picture of the environment around them, and they will enable us to use that picture as a reflection onto our objects. So it works very, very well, and it's very fast. So again, it enables us to have this real time. The only thing about the reflection probes is that they are a little bit, they're inaccurate, because they will take the reflection from one spot only, and sometimes that won't do, especially for us in architecture. Reflections are very important. So for that, we've got screen space reflections, and we've also got planar reflections, which have been implemented more recently, and those work very, very well. So I'm going to So how do we get a clean render with these soft shadows, which is what we're trying to achieve in in all our renders. So for that, I'm just going to show you a little bit the setup I've got for this kitchen scene here. So the skylight is actually, I'll talk about the skylight in a second. Just before that, I'm going to point out these light mass portals here, where they are very useful to direct the rays of the skylight into these openings, and I recommend using them because from what I've noticed, it greatly increases the quality of the light inside, and obviously may make things a little bit quicker. In the skylight, I've used this flat gray cube map, which I'm not going to go into more detail here because we have got not much time, but in this instance, you can see that I've put an intensity of 10 and the cube map flat gray. So we'll go over that in the next model, in the next webinar, and I'll show you how to do that. Another thing in here was that we we had a flat environmental color, and the intensity was 100. I threw massive amount of light in to light this space, which was a little bit dark. Here, for those of you a little bit familiar with the light mass, I use the static light level scale 0.75 and 0.75 for lighting smoothness, and that works very well for me. I use these values all the time, systematically now. And the lighting quality, was quite high. I think it was for the last final render, but I usually keep it between 1 and 4. So for those of you who know these settings, that's what I've used for this kitchen scene, and it worked very well for me. So so I'll show you a little bit in this UI here. What I want to tell you a little bit more about how to set up these light map resolutions. So, and also while I'm here, I'll demo a little bit this fantastic new volumetric fog that we now have in version 4.16. So anyway, I'll talk about that in a minute. So here, what you want to do is when you have your scene, you press on your keyboard Alt and 0, or you go to this visualization and you go light map density. And this really gives you this very matrix-like, and this really is the matrix, because it's really showing us all these grids on these objects. And so what I'd like to just point out here is, for example, I've put a resolution on the floor. So if I find my resolution, here it's 840. I don't know if it should be power of 2, 256, 512, 1024, or if these figures, to be honest, it works for me, and I don't put in power of 2, and so I assume it's fine. But so this floor here is slightly orange, and it's got a resolution of 840. If I click on this sort of guardrail here, it's only a resolution of 264, but they have the same, more or less the same resolution, which I'm looking at the grid, the size of the grid here. So to just apply one figure over the entire model, and if you think, for example, that 1024 is a high resolution, well, it might turn out that when you look at the light map density, it might not be high enough, or that if you apply that to a small object, it might be way too high. So this is what I do on all the scenes I work on now, is press Alt 0, and I'll spend quite a bit of time going through each one of these objects and maybe do some tests to see what is the right resolution. And I tend to try and see how fine this grid is so that my shadows look proper, look accurate, and so on. So here I've actually changed it so it's disappeared, but hopefully that makes sense. Right, so carry on because I see the clock is ticking. And oh yes, so I'll well, I've missed it because now I've closed it, but what I wanted to also show you on this, actually let me just restart it. I'll carry on talking on the image. Go back to full screen. And so here we've got static or dynamic lighting. So again, we talked about that for the objects, and for the light, it's a little bit similar. So our static and stationary lights will be baked into the GI, and the movable lights will not be baked into the GI. So if my kitchen started now, so I can put it back on. So here, what does that mean? When I did the scene, I lit it without the sun, and so that was that worked well enough for me. And what I thought is that I could do a little, I wanted to play with this, and so I could do a little animation for my client or something like that. So here you can see that when I turn the sun on and off, the sun doesn't affect the lighting inside the room. So that's really where we see the movable light at work, and where you will see effectively these renderers layered on top of each other. The light illuminates the scene but doesn't affect the GI, and it works well enough. If we had it on stationary, it would have been baked in the GI, and then if I move the sun, I get this preview everywhere, which is a bit annoying. So this is a great way to not only turn that preview off, but also that means you can move your sun around. And then here again, with this fantastic volumetric fog, that looks very, very cool. I'm sure it's going to be seen in a lot of architectural visualization because it's very exciting. Anyway, so we'll here again, just to show the opposite example, this light was set effectively, I've got it as movable here, but it was set to stationary. And if I turn it off, you'll see that there's still some lighting information here, because that light was actually baked into the light mass. So here it's a bit confusing because I've got it on movable, but when I calculated the light map, the light mass, it was set on stationary. And when I turn it off, if you want to allow your clients to turn lights on and off, you should really have your lights are movable, so that they when they're off, they should look properly off. Right, so I hope all this makes sense. I'll quit that and do my little dance for the last one there. Okay, and then we go back on. So now, quickly on materials, and again, we've got something new. It looks pretty complicated. This is the nodes material editor in Unreal, and we've got all this stuff and all this math. So what I'd like to say for, if you're starting out and you're looking at this and you're thinking, oh my God, another massively thing, and, and you think, I'm not a programmer, I'm not a maths, I'm an artist. And this is, don't worry, it's normal. I thought that, but just to say that all these formulas in here, we can really ignore that, and it's really worth digging in because it works. It's extremely powerful, and it works very well with this very simple set of nodes. I don't use very complicated things, and with just the basic 4 or 5 nodes, we can do most things that we could do in Max. And so there's really not much to be afraid of. This is the typical setup that I use with a diffuse and a multiplier. So let's talk about that in a minute. Let's talk about that right now, actually. What I try to do is work always try and bring things back to something familiar. So I've got the material editor from 3ds Max. That's what we've been used to working with for years. So we've got the slot for a texture map here, and then we've got the diffuse, which is effectively, the number, which is effectively a multiplier of that amount. So what I try and do in Unreal is set up this material, and actually something I should really point out before I go on is that with the material in Unreal, we can then set up an instance of that material, which will then give us these sliders to play around in real time into the engine. So this is what I try to replicate with the Max setup here, that I have my diffuse color. So you see here in the original material, which was the base, I called it simple matte. I've got just this bland gray. And then here in my instance, I will change the color to gold, and I've got the diffuse. And here was my multiplier, which you find here, which in this instance I haven't used. But another thing to notice as well is that we're using values between 0 and 1, which are the proper high dynamic range setup. So this is something, for example, that you notice in 3ds Max. All our colors are from 0 to 256, which is a little bit confusing, really, when we kind of try to work in linear and high dynamic range. So we don't have this problem anymore. So that's good. So the other big new thing, if we're going to work in Unreal, is the PBR workflow. So what's this PBR? It means that we work with textures which are, for example, in the diffuse, it's called albedo, and it takes quite a lot of work to generate these textures. This is a screenshot from a website called Megascan, where you can buy these. We've got the normal, displacement, roughness, specular, all this stuff. So it kind of means it doesn't really lend itself to our usual workflow of grabbing an image off the internet and putting that into diffuse. It doesn't really work like that. We can get these textures from website like Megascan, or there's also the possibility, for example, when we use Substance. So we'll talk about that more in the future, but with Substance, we just directly create these nodes. Roughness, metallic, and so on. So that's something that is going to possibly evolve for us, where the Photoshop is going to, well, I read somewhere that somebody said Photoshop is a great software to edit photos, but maybe not so much to create textures. So there we go. We've got potential substitute here. So just a little bit more on this PBR workflow. These are kind of my understanding of it. So the albedo, we've talked about that as well. It's just the color information, void of any shadowing. The metallic, as I understand it, it's just a switch on off. Obviously, we can plug it at any value in there. So it's a rule that demands to be broken to play around with it, but it's good to know that something that it's either metal or it's not. The specular, the default value for specular is 0.5. So if you're going to use a white material and just plug in a texture, it's good to know that you will have specular turned on by default. My values, I find that lower values around 0.2 work very well, and then very subtle changes make a massive difference. And then the normal, I just say very subtle, because a lot of times it can be too strong. And so again, we'll talk about all this stuff in more detail during the webinar on material, but here I've left roughness for the end, and it's got special bold and gold color, because when you think about this PBR workflow, it all sounds very complicated and sort of all this new stuff. But in fact, in the end, I think it's making our lives much easier and much simpler, because this is where it's at. Here, the roughness is where we're going to spend a lot of time. Well, this is where I do a lot of my tweaking, because effectively these materials are, with a specular on, they'll be reflective by nature. They will be automatically reflective. You notice there's no reflection here. So it's all about how rough they are. So a fully rough object will be like a rough concrete or a brick or a stone, unpolished. And then if we bring the roughness down completely, where roughness is 0, will be a flat mirror. So it's in V-Ray that would be very expensive to work this way, where we'll have always glossiness turned on and with very high settings. Whereas here, we don't really need to worry about that. It's always turned on, and it's whether we want our reflections to be blurry or crisp. And there's no rendering cost to that. In V-Ray, it would take a long time to render. So this is a new way that we couldn't have really done before. So this is really fun to play with this roughness value here. So reflections, a little bit about that. Here we've got our reflection probes. So we've got these 2 probes. We've got the sphere and the cube. So the sphere works very, very well, but it's maybe more targeted for games, because for large exteriors, the sphere will take in the entire environment. And for us, in our architectural visualization, we've got orthogonal spaces. So the box reflection capture is more suited to these spaces. However, it's a little bit trickier to use because they overlap. So it took me quite a while to go over these and understand and place them correctly, so we have a correct thing happening when they overlap. Another thing to know about these reflection probes is that by default the resolution is quite low. So if you go to Edit and you go to Project Settings and you click on that Rendering tab here, and you'll see that you're able to change the resolution of your reflection capture. So maybe play around with that. I would say before a presentation, just make that, or if you send your project out, turn that up. Or when you finish working with your project, turn it up. When you're working with the probes, it makes things a little bit slow, and there's a bit of a delay, so it's a bit annoying. Maybe keep it low when you're working, but it's good to know that you can up these for the reflections. So I'll go a bit quickly because I see the time is ticking, but this is planar reflections at work in this lobby scene on that floor. So here you can see all the reflections are accurate. You know, the mullions are reflecting in the floor. The lady is there, and so I systematically use the planar reflections for the floor now. It works a little bit differently, gives slightly different results, but is very accurate. So just to know that obviously that they're very expensive in rendering time, so can't use too many of them. So that's the planar reflections. I was going to show you a little bit more about this this material very quickly. It's how, you know, the nodes I'm using are not complicated. So there's a multiply one, which is we've looked at already, and then this linear interpolation, which works a little bit like the mix material, the mix map in Max, where we can have one texture laid on top of another texture according to a third black and white texture. So this is the way I did this black floor here. So you've got 2 maps and they've got different tiling values. Again, you can see that the metallic and specular here have just got a value So that's just a straight number, and this straight number is not just a number, it actually represents a value of gray. So it's the RGB, the 3 channels that have the same value. So there's no, I'm just plugging in one value. So that's good to understand. And again, I've got this linear interpolation here, a little bit more complicated map for the roughness. Here, the normal, nothing too fancy, but it's just to keep it really, really subtle. That's mistake I see a lot of the time, too much bump map. Okay, quick texture tips. Sizes, again, is going to become more and more difficult for us to just grab a low-res texture off the internet. If you do that, I know I do a lot. And because we can roam around, we can put our nose right on the texture. And so low-res won't do. 2048 really for anything of high quality and above. I think Unreal even now takes 8K textures now. I've not done it, but quickly go back to Substance. It does no cost in increasing the texture size. You just change the output size. We've done all our work, and then we can put this is a 4K texture, and there's nothing to do. So it's something that's going to become tricky for us to do in Photoshop if we wanted to increase our texture sizes. Quick one as well, in Max we've got this tiling value, and here it took me quite a while to realize that you could just multiply this texture coordinate node here. So quick one there. All right, so just to finish, I'm going to give you a very quick one on the post-process. We'll talk about that again in the lighting, but this is very powerful. There's a whole subject in itself, and just to show that's the difference between an image which is pretty flat and then with a bit of post-process. So I'll just show you super quick what we've got in here. With my post-process volume, we did, there was quite a lot of it, quite a lot of work went in it, but the big one is to use this color grading LUT. So there's plenty in the documentation about that, and effectively it's just doing your adjustments in Photoshop, and you can add that straight in. That's very, very effective. And I thought I'd show you a little bit something which is a little bit confusing, because we've got this depth of field here, and that's quite a tricky one to use. That in order to do the depth of field, now we've got this new Cine Actor camera, and I'll just make that a little bit bigger here, and so that we have these Cine Actor camera, and we have, when the camera comes in here, you've got this lens settings, and what I do is that in order to play around with the depth of field, I bring my minimum stop to incredibly unrealistically low value, 0.2 here. And when you work with the Cine camera, you change your aperture, and that enables you. So here I'm on 22 and everything's crisp. And when I bring it way down, you see that so I exaggerate here, my foreground and my background gets incredibly blurry. So I use this debug plane here to choose where my center of focus is going to be. And so here I've got my chairs in focus, and then I can choose change my depth of field by changing the camera aperture. So it doesn't impact the exposure. The exposure still has to happen into here in the exposure of the post-process volume. So again, we'll talk about Tone Mapper and all sorts in the lighting webinar. Okay, and then so I'll just finish off very quickly. Interaction and output, that's a massive subject. We've got blueprints, we've got sequencer, VR, but I'll just say use the templates for VR and first-person shooter for navigation. You can navigate without them when you open the editor, but it's really worth using the work that's already been done there. And then just in output, quickly, if you're a freelancer, you're working in-house, there's a great value in just preparing files to be viewed in the editor with F11 to make it full screen NG, and you're there. So it's great for client presentations. If you haven't used, if you've got an Oculus or a Vive and you haven't tried the in-editor VR on version 4.16, do so, because I think it's really going to affect how we work in the future. And then all these other, I'm not going to go through, but they're really increasing difficulty, with mobile VR being the most difficult to output and deliver to clients. So high-res stills, I'd just like to point out here, the Ansel photography plugin is working very well, and it allows you to take stills up to 60,000 pixels across. So it's all there, it's free, and I'm not going to show you how to use it in here, but this is all on this page, and it works very well. Right, so if this is the end, if you want to know more, I've got a YouTube channel here, check it out. I haven't put much on there for a while, but I'm getting ready to put loads more. So go there, subscribe, and I'll see you on there. And then if you want to check out some of the courses I've done, you just go to my website and click on courses there, and I'll put the link in the chat in a minute. So there you go. I hope that was useful. And Chris, I'll hand back to you.
All right. Thanks, everyone, for hanging out. Thanks, Fabrice. That was really great. For those of you that have stuck around, hopefully you're going to get a little benefit about what we're about to show. We have the ability, lucky enough, where we can show you some things that we've been working on at Epic. So I'm going to go ahead and play back a video that I created that's showing some new technology that we've been working on. It's only about 5 minutes, and so after the video is done, we'll be moving on to the QA section, so don't go anywhere. So let me go ahead and fire this off, and it's going to turn off my camera, and you can go ahead and take a look, and we'll talk about it after we're done. Okay, so we're going to take a look at a technology preview of some things that we're working on at Epic. The goal here is that we want to make the adoption of the engine super simple for people who are doing design and architectural visualization. And we want to address some of those workflow issues that we're currently seeing with people who are using the engine. The biggest hurdle at the moment is getting data in a fast and efficient way. While there are certainly lots of different things to be considered when you're moving data into the engine, if we can shave off, a certain percentage of that work and make it a lot easier to do it, we believe that will really benefit our customers who are using the engine. So we've created some technology that really automates and accelerates that process. So I've got a V-Ray scene here, and it's V-Ray very specifically. We recognize that a lot of people are using V-Ray for their work in 3ds Max, and we think it's important to try to replicate that workflow as closely as possible in the engine. So I've got a V-Ray scene here that has V-Ray materials. You can see I just have some real simple V-Ray materials set up at the moment. I also have some V-Ray lights. So if I choose my light filter and I select the lights, you can see I have some V-Ray IES lights in here. I also have a standard V-Ray area light there. You notice that some of these lights are just white lights and some of them are colored. So pretty simple setup. I also have some CAD geometry in here. If I click this and zoom in on it, you can see I have a CAD model of a radio that came over. Thanks to Adrian Wise for sharing that with us. And finally, you'll also notice that I do have some cameras in the scene. I have a standard camera here, and I also have a physical camera here. So two different types of cameras in the scene. Let's go ahead and move these things over to the Unreal Engine so you can kind of get an idea of some of the things that we're working on. So I'm going to go ahead and choose File Export, And I'm just going to overwrite one of the files that I used previously. So we'll just say yes to that. So I've blurred out some of the things here, but you can see that basically we have some choices about some of the things that we want to assist with in terms of moving data from Max over to the Unreal Engine. So we have a couple of different settings there, but again, there's no guarantee that any of these things may actually end up in whatever piece of technology we should make available. So I'll just go ahead and say export to there. And we'll let this thing export automatically. We'll say OK there, and we're done. Now let's hop over to the Unreal Engine. So now you can see I have an empty level here in the engine. I'll just go ahead and do File Import, and we'll go get that preview file. And again, just blurring out a couple of things, but you can see we're going to have more options here. And we'll go ahead and import everything. And this does take a few minutes, so I won't cut the camera away, but I will actually accelerate this so that we're not sitting here waiting. Okay, so our content has been brought into the scene, and you can see there's really good parity with what we're seeing in the Unreal Engine versus the 3ds Max viewport. You may also notice that all of the materials are hooked up. We recognize that that's a big challenge sometimes, so we want to automate that workflow. Again, it's not necessarily a one-click solution, but it's as few clicks as possible. We're trying to make it easy and simple and quick to get your content into the engine. So you can see that our lights are here. Those have been brought over. You'll notice those are V-Ray lights over in the scene. Our area light has come over. Also, the individual cameras that we had in 3ds Max, both the standard camera and the physical camera come over, and each one of these cameras is different in Unreal. This is the standard camera in Unreal, and this is the cinematic film camera that's in Unreal. The other thing that we should take note of is in our world outliner, all of our objects have come over. We've respected Max layers. If I choose the layers tab, you can see those are the same layers that we had in 3ds Max, but also all of the objects are grouped by type in the world outliner. So cameras are in one folder, geometries are in another, lighting is in another. This is going to make scene organization super simple. We recognize that scene organization is a really important part of the workflows into the engine when you're coming from places like 3ds Max or other CAD packages. We know that that is going to be really important to you. You can also see that everything has been organized in our content browser. File folders have been created. Everything is in its right spot. You'll notice that each individual object has been brought in as a separate FBX file. So you can work with them in the engine or in 3ds Max. You're not stuck working with one single FBX. So again, just a little technology preview. Hopefully we'll have some more to share on this as the year goes on. So we'd love to hear what you think about this. Please feel free to leave some comments in the chat, and hopefully you'll be able to see more of what we're doing as the year rolls on. Okay, everyone, that was our technology preview. So hopefully you got some good information out from that. So I think Fabrice is still in the room. So Fabrice, if you want to turn on your camera, let's go ahead and jump into QA. We have about 10 minutes for QA before we end the session. So I'm going to go ahead and I'm just looking at the complete list of questions there. Some good comments on the technology preview. That's great. So we had a lot of questions roll in. So I'm going to start with some of the earlier ones, and we'll just kind of move back. So Fabrice, are you able to troll through the questions and see them on your control panel? All right, great. So easiest question to answer, where can I access webinar number 1? I think someone put the link in the question and answer, so it should be right there and readily available. Let's see. Revit has a plugin, an Enscape one-click solution. But how will Unreal get a more streamlined pipeline in for architectural viz? I think we just saw that in the tech preview. So we don't have a timeline yet on when that stuff is coming out, but or what it's going to look like in its final form. But we're definitely, I think, within the near future, I think we're probably going to be able to share some news in that regard. First webinar was answered. Matthew, how can I go from Unreal VR to mobile VR like Gear or Google VBR? I think Anea posted a link to that in here. Fabrice, do you want to talk a little bit about scene cleanup and talking about manually renaming files and objects, and how important is scene organization when you're moving all these types of geometry over to the engine?
Well, like I said, it's going to depend a little bit on how you want to handle the workflow over a longer time. If you want something very quick and just to throw it in there and have a look, and you're maybe in at very early days of the project, and you just want to have a quick client presentation, and then you're going to have lots and lots of changes, and it's not worth. So you can just go at brute force, like I showed you. It works. There's just a little bit of problems to sort out, and then you can look around, but it's going to cause you a lot of problems in the future. It kind of means use your common sense, but I've figured that out for myself. Went back into projects and it was just a complete mess, and regretted not being too organized. So I use the renaming in 3ds Max, and like I say, I've looked at that Unreal naming conventions, and it's good, to have a look, and it's good to know. Take whatever you think is useful.
Okay. How would you optimize a big scene for Unreal? I think there are several different approaches. Kind of picking up on the last question, scene optimization and scene organization is really important. I think it's, Fabrice, do you use layers or groups, or how do you clump objects or cluster objects together? Do you do it by object type? Do you do it by furniture type, or how do you organize your scene?
Yeah, so like I say, when I get a project in, I'll just sort everything out by material. It makes sense because it's visual to me, and it's very easy to pick. When you get CAD data, it's very easy to pick a material just by its color. So that's usually what I just go straight in to organize things at. And then afterwards, I'll do subdivisions of that. I don't really use groups because I like to be able to have very hands-on control over my objects. And so I'll just grab a bunch of objects and use that TS tool script to export it, and do it systematically, step by step, like that. I think we have to remember that Unreal is not a CAD program. It's a game engine, and in game studios, it's very strict. People spend a long time on one object and make it very watertight and proper. So that's what the engine is made for. And I think we need to kind of accept that. And if we're going to work on things which will take have a longer lifeline, we'll need to be a bit more disciplined like that.
Right. One Gabriel asked, what were the light settings you were using to get the shadows so soft? I think that was in the kitchen scene when you were working on volumetrics and things like that. Can you give us a little bit more info on that?
Yeah. So like I said, the smoothness of the lighting is really going to depend on the resolution of your light maps. So you have to go in the editor, and again, I do it object by object. So I know it sounds a bit tedious, but that's how you're going to get the good quality, is by going bit by bit, area by area, and changing your light map resolution to be right using this Alt-0 on your keyboard. And the thing about that is that it's going to massively increase your render time. So for example, for the lobby, that was just for one. On my one machine, it was 9 hours all night it took to calculate the solutions. So but I pumped everything up to quite a high resolution. So there's no there's no secret, there's no magic. You need to have high resolution in your light maps, and that's going to cost you in render time.
Okay, cool. I notice also when it comes to light map and light mass in general, besides the light map resolution, good UVs are a requirement there. You kind of alluded to it, where you go back and touch each one specifically. Frequently, what I do is I'll start off with a basic UV using the automatic unwrapper from the things that we linked in, like Steamroller or the Chris Jennings unwrapper, and then I'll see where my problems are. The thing I like about Steamroller is it'll unwrap the entire scene all at once. It saves me time for just getting basic UVs on all the objects. And then I can go back in and find the problem areas, if it's just the walls or if it's just a couple of objects, or, I only unwrap things that are obviously visible to the camera, or if they're what I call hero objects, if they're things that are going to be up close to the camera, if there are things that the camera is going to linger on where the eye can kind of pick apart the surface, real subtle, breaks in the lighting or shadows. So when you're doing light maps, better UVing is an additional troubleshooting method to solving, light baking issues. If the shadows aren't baking correctly, take a look at not just the resolution, but also the UVs on there. So,
and effectively, if you have a bad layout, a bad UV layout, one of the solutions is to increase your light map resolution, because that's effectively going to sort out the problem. The only problem with that is that it's going to increase your render times as well. So if you have a good UV layout, you might not have the problem in the first place, but also you might be able to use a lower resolution, which will you gain tremendous amounts of time in rendering.
Mm-hmm. Okay.
I see
go ahead.
Somebody had a quick question about swarm agents got kicked off when I try to bake. That's what swarm agent does. It's the renderer kicking off, basically. That's why you can still work in Unreal while it's rendering, because it's offloading everything to the swarm agent.
Great. And then Anand asked how to render 360-degree image in UE4. I think that Ansel Adams plugin will do that. I don't know if Anea is still in the room. Anea, one of our tech artists at Epic, he could jump in on that, because he just sent me a couple yesterday. How to bake a light map for just a single object and retaining the light maps for the rest. Is that? I don't think that's the thing yet, is it?
I think that's a great idea, and we should put a suggestion to Epic.
Right. Absolutely.
Well, apparently Unity does it, so yeah.
Right. So
right to Epic.
Right. So, well, thank you, everyone. We appreciate your time. I know this was a much longer webinar than the previous one. That was one of the feedbacks that we got, that we could have gone a little longer and a little more complex and technical. And so hopefully we accomplished that for you all. Like I said previously, we're going to be having some other webinars coming up, so stay tuned on that. Again, I want to give thanks to our friends at Tilt Pixel for providing some of the content that was used in Fabrice's presentation, and Adrian Wise for some of the content that was used in my tech preview, and of course the models, some of the furniture models in my preview were provided by TurboSquid. So I want to thank those folks as well. So everyone, I really appreciate your time. Fabrice, thank you for a great webinar. So like I said, folks, stay tuned. You're going to be hearing about webinar number 3 fairly soon, and we appreciate your time. So I'm going to go ahead and turn off the chat now, and we'll get ready for our webinar in our next time zone. So thanks, everyone. Have a great day.